in the denominator for this whole section. So number 9, luckily, there's no fraction, so we don't have to worry about that. But the number 384 does not have a 7th root. If I try to do 7th root of 384, it doesn't work. It doesn't come out to be a whole number. But what I can do is try to split this up into something that does have a 7th root, and its factor. And so we don't have our 7ths on the back wall, but let's just start with something as simple. I always start with 2 and go 2 to the 7th, which is 128. I'm going to see if 128 goes into 384. So 384 divided by 128 is 3. So this does work. We're going to use 128 and 3. The reason we used 128 was because its 7th root is just the number 2. So then our simplified answer is 2 times 7 root 3. 7th root of 3. 7th. Yeah. Now you don't have a ton of that are that hard. Most of them will be numbers we use that are in the chart in the back wall. Okay. Number 10, the 3rd root of 5/9. So in the previous example, it helped to leave these numbers that are in the radicand as a fraction, then we could simplify. But does 5/9 simplify? No. So in this case, it would be good to actually go the opposite way and break these apart. The cube root of 5 and the cube root of 9. But then the problem is we still don't have a cube root of 5, and we don't have a cube root of 9. But we're also not allowed to stop here. Because one of our bullet points said if we want simplified form, we cannot have a radical in the bottom. And so I need to do a little bit of thinking in my head to figure out what can I multiply by here, top and bottom, so that I end up with a number that has a cube root. Ideally, this is what we're trying to do. I want to have just a whole number down here where I'm putting my pencil. And so what can I multiply by so that I have a cube rootable number? 3. The cube root of 3 times the cube root of 9 is the cube root of 27. And cube root of 27 is just 3. So the idea is, this is what, if you don't know where Mason got that from, is I knew that my goal was to get a cube rootable number. So it has to be 1, 8, 27, 64, 125, 216, 343. It has to be one of these numbers. I want to use the smallest possible, and I knew that 9 times something was 27. And so that was my goal, was to get to the 27. Could I have done 9 times the cube root of 9 to get cube root of 81? Yes, but then your answer wouldn't be as simple as it could be. This is going to be as simple as it could be when we're done. Now, what I didn't do yet, because we were talking about just the thought process, is if you multiply by root 3 on the bottom, you have to do the same thing on the top. And so then I multiply here, the cube root of 5 times 3 is 15, and we can't simplify that because there's no cube root of 15. And so then that's our final answer. Don't make the mistake of trying to divide the 15 by the 3. 15 is a radicand, 3 is not. You can't divide numbers that are like outside of the radical and then numbers that are inside. So we're done at that point. Okay, the next 2 examples deal with that conjugate idea I talked about on the front page. You'll see what happens when we do this is that if I want to get rid of the radical on the bottom, on ones like this, we can multiply by the conjugate. 4 plus root 5. 4 plus root 5, top and bottom. When I multiply by 4 plus root 5 on the top, we just distribute the 1 into both of the terms. So 1 times 4 is 4. 1 times root 5 is root 5. But on the bottom, it's going to be a little more work because I have 1, 2, 3, 4 terms. And they all have to multiply together. And so watch what happens. 4 times 4 is 16. 4 times root 5 is positive 4 root 5. Negative root 5 times 4 is negative 4 root 5. And negative root 5 times positive root 5 is negative square root 25. But what's very nice, and it happens all the time with conjugate multiplication, is that these 2 middle terms, the 4 root 5 and the negative 4 root 5, cancel out. And square root of 25 is just 5. So I have 16 minus 5, which is 11. Now I'm done because I don't have a radical on the bottom anymore, and that's part of simplifying radicals. Okay, so take a minute to write that down, look back at the work, does it make sense? And then think about what would you do for number 12. What do you think, John, we should do for number 12?
Don't ask me, I have no clue.
No, what did we do for number 11? We multiplied by this thing. What was this thing called?
That was called a radical. That was called stoning, no.
Conjugate. Can you say it? Can everybody say conjugate?
Conjugate.
Conjugate. Okay, if I was to give you a tip on your test, remember you get those sometimes? I might say, use a conjugate. But if you don't know what that means, it doesn't do you any good. So some of you have to be working with the vocabulary a little bit. Okay, so we're going to use the conjugate, which means we're going to multiply by, well, last time we multiplied by a positive in the middle because this was negative. What do you think we're going to do here? 1 minus root 6, top and bottom. On the top, it's pretty simple because it's a single distributing. Square root 2 times 1 is square root 2. Square root 2 times square root 6. Oh, this actually might be a little more work because this is going to be square root 12. And this square root 12 will be able to simplify in a minute. Let's just wait a second, though, on that. On the bottom, when you distribute, you get the 1 times 1 is 1, negative square root 6, positive square root 6, negative square root 36. The two square roots of 6, positive and negative, cancel out. We get 1 minus 6, which is negative 5. Bless you. This is where we don't want to stop because, yeah, we don't have any radicals in the denominator. That's good. But we do have a radical that can be simplified. The square root of 12 can be simplified because 4 is a square number that goes into 12. And so I'm going to do the work just above here. Square root of 12 is the same as square root of 4 times square root of 3. That means that this square root of 4 is 2, so we get 2 root 3 instead of the square root of 12. So that means I have square root 2 minus 2 square root 3, all divided by negative 5. And that is simplified form. I know it doesn't look simple, right? But it's technically simplified because of those 3 bullet points that we need to meet those requirements. Okay, so there's a few other things we're going to learn in this section, but we're going to hold those for tomorrow. Today, everything you do is going to be based on the stuff we just did. Your homework assignment is page 248. I'll put them up here. Do make sure you put the section number on your homework.
Yeah.